In this video, we will be demonstrating the FDTD solver in Feko using a 4-port microstrip coupler on a finite substrate. So this model is part of the example guide we have for Feko. So you could find this under Application Macro in the macro library. So inside the Application Macro library, search coupler. You can see it's this EGE5 example for the microstrip coupler. Click the Run button and it automatically loads the file here. So now we have our microstrip for coupler on the finite substrate loaded into our CAD Feko session. You can see all 4 edge ports in the model here. Additionally, we could only see half of the coupler, which is on the top of the substrate, right? And the other half is located here on the bottom of the substrate. So we are now going to go and try to gain some more insight into this coupler. So go into display options. We're going to create a cut plane to see on the inside. With the default cut plane selected, we can now see the inside of the substrate. Alright, so now we're looking pretty much at the bottom face inside of the substrate. We can see the 4 edge ports, so we see edge ports 3 and 4. We're only looking at the very bottom portion of it. But edge ports 1 and 2, we can see are going from the bottom trace of the coupler up to a middle face above it. If I move the N origin up a little higher, you can see 4 edge ports connecting to this intermediate ground plane, as well as 4 apertures for the coupler. And so now if I flip the cut plane, you can see edge ports 3 and 4, and the top face of the coupler, similar to like how we saw the bottom. So by default, just loading this example into CAD Feko, we can see that frequencies are already set, so we already have a pre-built mesh ready to go for our simulation. So if we select to display the mesh, we can already see that we have that voxel mesh elements pre-generated here for our model. So our model is already imported for FDTD simulations, so if we go into the Solve Run tab, FDTD, we can see that we have activated the finite difference time domain solver. We will quickly investigate the mesh of the FDTD solver. So clicking into Modify Mesh, we can see how the model is set up with its voxels in X, Y, and Z directions. Right? And we're going to keep it in standard mesh, but we can go into advanced setting and see how we can adjust the mesh to refine it in certain places. Again, keep it standard, click OK. If we go into our Configurations tab, we can see the boundaries of the FDTD simulation in green. And this, by clicking the FDTD boundary conditions in the Solve Run tab, we can see that the results open up here. So we automatically add a free space buffer for all of these faces, but you could specify, if desired, the free space buffer. Additionally, we already have an S parameter simulation set up. So right now we just have edge port 1 that is active, and we can see that here, shown as the edge port has the voltage source. So we do have this S parameters configuration set up with all 4 edge ports, however just the edge port 1 is being excited. Okay. And here, clicking the Feko solver, go ahead and invoke the solver and we can run the simulation. And while running in FDTD, we should be able to see in the output status that we are using FDTD, see right here, and we can see the estimated number of time steps over this interval. Okay. We'll let the Feko solver run and reconvene once when the simulation is completed. Alright, so the simulation is finished running. So now we are in post Feko. You can see the 3D view of our coupler here. We'll create a Cartesian plot. And with this, we can start plotting the S parameters of our microstrip coupler. So I'm just going to go ahead and add 4 traces to the rectangular plot. And so the first trace, S parameter, is S11. Second trace I'll change to S21. The third trace I'll change to S31. And then the last trace I'll change to S41. Okay. So this concludes a microstrip coupler using the FDTD solver in Feko.